In this lecture, we're going to talk about the two-tailed test for hypothesis testing of the mean. And our idea here is we're going to set the value of our mean to be a particular value. Here it's set as 0. Okay. And then after we have it set, then we take samples. Okay, we can take samples, and basically when we take our sample and we get the mean of our sample, that mean can fall any place along this axis. It can be here, it can be here. Most often, if this is our mean, our the mean of our sample will fall here. Now, there is a probability that it could be anywhere along this axis, but the idea is most of the time it will be here, and so we're our mindset, if we get too far from that, we say, okay, it can't get too far very much of the time, and so we're simply not going to believe it anymore. So our hypothesis test is a formal process. It's like doing one is like filling out a form. We have 3 parts. The first of this is the hypotheses themselves. The second of this is our test criterion. And the third part is where we do the calculation and the decision. Okay. When we developing the hypothesis is something that in practice will be done over a period of time, okay, and it's something that in all likelihood this is going to flow from whatever subject that you're in. You'll draw upon the particular knowledge of the practice you're in, or the job site that you're at, okay, so that's something that you're not really going to have to worry too much about, okay, and it's hardly ever going to be done in terms of the way homework exercises are done. For a two-tailed test, our null hypothesis, okay, for a two-tailed test, our null hypothesis will look like this. It'll be in the form mu is equal to mu naught, and this mu will always appear as it is. It's a symbol denoting the mean. This mu naught is a stand-in this for a particular literal value. So you write this down, this is going to be mu. That's what it's going to be. When you write this down, this will be a 4, a 12.1, 38.6, whatever. Okay. Now, once you have your null hypothesis set, your alternative hypothesis is just a logical negation of it. For a two-tailed test, the logical negation of equal is not equal. So this part, getting from your hypothesis to your from your null hypothesis to your alternate hypothesis is never going to be a problem. Okay. Our test criteria. This is the part of the our hypothesis test where it gives us the rules. Okay. It gives the directions for the person carrying out the test, what he needs to be done. And before we get to that, before we can set it, we need to determine the significance. Again, the significance is going to be done, come from the standards of the practice you're in. It'll all depend on how precise and how careful you need to be. 95% confidence is very common. Some folks like to have, I guess, 5% significance. Okay, 95% confidence, 5% significance is very common. 2% is common, 1% is common. Getting much larger than that, you're getting into things that you really don't have very much confidence in. Now, this part of the test criterion is called your test statistic. Okay. This part is called your critical number. Okay. And this Z value here, this is exactly the same Z value that you use when you're doing your confidence intervals. Okay. Now the calculation and decision is the final part. Okay, you only do this after the test criterion is set up. If you do your test and then set up your test criterion, no one is going to believe you. Okay. But after your test criterion, then you take your data, you take your sample, given that sample, you perform your calculation. Then when you get the number, having calculated the test statistic, you go back to your test criterion and make the decision on the basis of that. If your test statistic is too big, if it's too far from, if your X bar is too far from the mean that you can believe this anymore, you reject your hypothesis. If it's not, then you do not reject the hypothesis.